Okay, example number 4 here is going to have us trying to graph a periodic function. So they give us this situation. New York's Eldridge Park Carousel is considered the fastest carousel in the world, taking riders for a spin at 18 miles per hour. The indoor carousel has a diameter of 50 feet and can complete about 10 rotations per minute. Okay, so 60 seconds in a minute. Sounds like we're doing about one rotation every 6 seconds to make that happen. The distance of the rider D from the front wall of the building varies periodically as a function of time. Identify the period of the function. Well, the period, just like I said, would be 6 seconds, right? Because it takes 6 seconds to make one rotation if you're going to do 10 rotations every minute. Then graph the function. Assume that a rider begins at the point closest to the wall, 20 feet from the wall. Okay, so this is what we're talking about. We're on a carousel. This is the Eldridge Park Carousel specifically. And we want to say, make a kind of general sketch of a graph of what we'd expect for the distance from the wall. Okay, so here we have that picture kind of laid out. We're 20 feet away from the carousel. We're going to start at that distance. So at time 0, we are going to be 20 feet away. 6 seconds later, we should have completed a rotation. We should be 20 feet away. 6 seconds after that, another rotation. Halfway there, so every 3 seconds, we should make it out to this point. So that would be a distance of 70 away if it had a diameter of 50. We're already 20 away. So at 3 seconds, we should be at 70. That should happen 3 seconds after, 6 as well. So at 9, we would be at the same point. And out here, if the graph went out to 15, there'd be a point right there. In half of that time, every second and a half, we should go half that distance, half the way out to the maximum. So at time, let me see if I get this right. 3 seconds, we're out there. Yeah. Oh, they're going this direction. That's why I was confused. So at 1.5 seconds, they should be half that distance. So at like 35, 70 should be at, what is it saying 45 here? Should be halfway around. Half of this thing will be 25, another 20 makes 45. Okay, that's why. So we should be at 45 at 1.5 seconds. Okay, just basically right in the middle of that one, right in the middle there, 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 and there. Now as we connect these, we want these to have rounded tops and rounded bottoms. Okay, and that would be our kind of approximate, pretty close approximate, I think, graph for this function. Okay, so if we were to make the function as like an equation, we could make it either as a sine function or a cosine function. We just need to learn how to kind of move around our standard baseline functions in order to do that, which is what we'll get to in a lesson next week. Okay, but I think that's all that it would take to get through that example number 4.